Let's talk about separations, and we're going to get to chromatography in a second, but if we talk about something like solvent extraction, then it will sort of hopefully make it an easier connection for you what's going on when we get to chromatography. So, basically, let's talk about something called the coefficient, or the partitioning coefficient. And so basically this is like if you had, I don't know, salt or something in water, and you added some oil, and the oil and water separate, but you want to think about how the salt is going to partition between the water and the oil. So like salad dressing. So basically the way we describe that is the activity of whatever your, like activity of X, your salt or whatever solute it is, activity of that in the phase 2 over the activity of that in the phase 1. So let's think about this as X. So the concentration of X in solvent 1 underneath the concentration of X in solvent 2. So another way we can think about this, for the same expression, we can write it as Q, where Q is the fraction of X in the solvent 1 times the moles divided by the volume, so basically the sort of the molarity total, so the total moles divided by volume 1, and that's underneath 1 minus Q, so there always has to be a 1 or 100% of Q, so 1 minus Q is the amount that's going to be in solvent 2 times the total number of moles of X divided by the volume of phase 2. So, and you can work this out and solve for Q. Q equals volume of 1 divided by volume solvent 1 plus K times volume solvent 2. And you can either work that out for yourself, or I can do it in class, or you can just accept it. Either way. So that's equal to Q, where Q is equal to the fraction of X in solvent 1. And when I say solvent, it could be water. All right. So now let's talk about a somewhat more complex situation. We were talking about the partitioning coefficient, where you just have a solvent or a solute that's always sort of the same thing. Now let's think about where you have something where it could be protonated or deprotonated, and you could have both of those states existing. So here we have a base with H plus that can protonate at different pHs, so as a function of pH. So let's talk about the distribution coefficient now, which is essentially the same thing as the partitioning coefficient. So we're talking about the amount of X, or in this case B, in the organic phase divided by the amount that's in the aqueous phase. And the charged species is always going to go with the aqueous phase, because the organic solvent isn't going to like something that's charged. It doesn't like that. And it can hydrogen, this charged species can hydrogen bond with the water and stabilize itself and feel much happier in the water than it feels in the organic solvent. So basically what we're looking at is the concentration of B in the solvent divided by the concentration of B in the water plus the concentration of BH in the water. And you can work this out, and that's equal to K, the partitioning coefficient, times Ka over Ka plus H plus. You could also write this as K, the partitioning coefficient, times alpha B, where alpha B, we didn't really talk about this, but it's basically the concentration of B in the aqueous phase divided by the total concentration of B, where you have B, where it can only exist as B and BH plus. So the amount of B that's in the unprotonated phase. Alright, so now let's talk about chromatography. So chromatography is essentially the same thing as solvent extraction, only now you have a solid phase and a stationary phase and a mobile phase. So your solute is going to start out in the mobile phase, and it's going to flow over or across or through, however you want to think about it, and it sort of somewhat depends, and we'll talk about more specifics on this later, through or past a stationary phase in a column. So your solvent is called the eluent, and that goes into the column with your solute, and then different things travel through the different solutes travel through the column at different rates for a variety of reasons, which we'll get to, and then it's called the eluate when it comes out. So chromatography is the process of separating a mixture into its components, and elution is sort of the process of passing a liquid or gas, your eluent, through a chromatographic column.